we've got some applications for for common and natural logs, and they're pretty common actually in science and in well, like for instance some of the programs that some of our students are in. And so we're working on section 5-10.5, common and natural logs. So use the calculator to find the common log. So on our calculator, we would press log. Where's the log key here? It's about, well, it's the second row down, the second one from the right. So we would press log 60 equals, and our calculator says 1.7782 because it wants it 4 decimal places. Number 2, we would press log 65.2 and we get 1.8142. All right, how about this one? It's log 0.00672. Now we would expect it to be negative because it's less than 10, so it would be negative 2.1726. Number 4, now we have natural logs, so it's ln, which is a key right next to the log key, 51.71, and it comes out to be 3.9457 when you round it to the nearest 10,000th. ln 0.0415, we get negative 3.1821. ln 246.3 is 5.05, no, 5.5066. Number 7, ln 2 is a little bit less than 1. It's 0.6931. All right, now we've got an application that has to do with the hydronium ion concentration in science. All right, the thing that you have to know about this is that pH equals negative log of the hydronium ion concentration, H3O positive, or in this case, H positive. It's the same thing. So if the hydronium ion concentration is 3.6 times 10 to the negative 11th, we should take the log of that. So log, parentheses, 3.6, and then I'm going to use the times 10 to the key, which is next to the answer key down at the bottom, times 10 to the negative 11th, and we get negative 10.44. But remember, it's the negative of that, so we should change the sign to make it positive, and it'll be 10 point, and it wants it to the nearest tenth, so it'd be 10.4. All right, same thing here. The hydronium, the pH is 4.7. Oops, cancel. Whoa. pH is 4.7. So in other words, the hydronium ion concentration is 10 to the negative 4.7. which would be approximately 10 to the negative 4.7 moles per liter. Use scientific notation. So we will do clear 10 to the 4.7 equals, and they want that in scientific notation, so I'm sorry, it's negative 4.7. 10 to the negative 4.7, and we get 1.99, which is actually 2.0 times 10 to the negative 5. Okay, so for this one, we would press 10 to the negative 3.7 equals, and our calculator says 1.995, 2.0 times 10 to the negative 4. Okay, number 11. Now it would be 10 to the negative. Remember, you have to change the sign. 3.4 is 3.98. We want to round that to the nearest tenth, so that would be 4.0 times 10 to the negative 4th. Number 12. Now we've got the formula for the loudness in decibels. This is like example 6. The loudness in decibels is given by the formula loudness is 10 times the log of I over IO, where IO is 10 to the negative 12th watts per meter squared. The intensity of the sound is 5.6 times 10 to the negative 6th watts per meter. How loud is this music in decibels? So we would take loudness is 10 times log, and then in parentheses it'll be 10 to the negative, or I'm sorry, this number right here, 5.2 times 10 to the negative 6th over 10 to the negative 12th. Okay, so let's press it on our calculator. 10 times log fraction 5.2, and then I'm going to press the times 10 to the key, negative 6 over 10 to the key. Oh, no, I'm going to delete that. It should be over 10 to the key, negative 12. Yeah, don't press the times 10 to the key. And you get 67 decibels. You round it to the nearest whole number. Yep, 67 decibels. All right, use the logarithmic change of base formula. Come on now, don't do that to me. Logarithmic change of base formula, which is, let's see, page 606, which says the log base A of x is the log base B of x over the log base B of A. Since we want it, we can use either the natural logs or the common logs. So I'm going to write log of 12 over log of 6. All right. So we would press that on our calculator. Log of 12, clear. Log of 12 divided by log of 6, oops, clear. Log of 12 divided by log of 6, I had to close the parentheses, and I get 1.3869. Last one will be log of 60, close parentheses, divided by log of 5, close parentheses, equals 2.5440. All right, if you have any questions, give me a holler.